Hello and welcome to another CS Tutor Center video. Today we're going to talk about the problem subarray product less than k. But before we get started, if you enjoy these videos, let me know by subscribing to the channel. When you subscribe to the channel, it lets me know that you want me to make more of these videos, and as a result, I'll make more of them. Also, if you could help me out and like the video, that will help reach this video to more people, which will motivate me to make more of these videos. All right, so next, this problem is going to fit into two categories. We can solve it with a sliding window, and you can also think about it as a two-pointer problem. So as a result, inside the video description, I'm going to provide a link to my sliding window playlist, and also a link to my two-pointer playlist, where I have a series of videos that shows how to solve Leetcode problems using those different coding patterns. And then lastly, I'm going to solve this problem using both Java and also Python. So you can learn how to solve it with either of those languages. And if you look in the video description, I put down timecodes. So after I show how to solve the problem, when I get to the coding aspect, if you want to go to Python, just click on the timecode that will take you straight to Python. Or if you want to do the Java, that's the one I'm going to show right after I show how to solve it. Okay, let's begin. So given an array of integer nums and an integer k, return the number of continuous subarrays where the product of all these elements in the subarray is strictly less than k. Okay, so let's analyze this. When we look at this problem, we see the example has these numbers and then k is less than 100. And what we can see is the subarrays that ended up working. And so we can see that when we start thinking about how to do this, we want to think about our coding patterns that we have learned in the past. And if we run through our mind about, two pointers, sliding window, and we think to ourselves, like, what if I have 10 and that works as less than k, so that's 1, and then 10 times 5, that's 50, so that works, that's another one, and then 10 times 5 times 2, that doesn't work. So in the past, when we solved sliding window problems, when we realized that a particular window doesn't exist, then we, based off how the problem was asked, we would shrink the window from behind like that, or we would keep that window size and just slide it to the right. If we shrink from the behind in this scenario, it wouldn't quite do it right, because we'd have 5.2 and then we have 5.26. But if we shrink from behind and then restart where we have 5 and then go to 5.2 and then 5.26, it's looking like that could work. So we're thinking to ourselves possibly a sliding window problem, and we'll get into this more when we head over to the blackboard. But before we do that, let's look at the constraints so we can take into account, we can look for other clues as to solving the problem, but also take into account like what variables we're going to use, because when we take the product of something, we got to make sure that we're going to use the right variable to store that can hold that data. If you're in Python, you don't have to worry about that, but if you're in Java, then you got to declare the data type ahead of time, and you got to worry about that. So when we look at this, the nums value, it's pretty small. It's just 1,000. So you think to yourselves, okay, so it's 3 to 10 to the 4, and in the worst case, I would multiply all those would be 1,000, and I would multiply all those, and then you realize that that would fit inside of an integer. So we could use an integer for keeping track of our current product. The k could be 0. So if it's 0, then this needs to be strictly less than k. So we're not going to have any results if it's 0. So we're going to have to do an if check at the beginning to handle that special scenario. Okay, let's head over to the blackboard and start working on this problem. So we'll look at this example. Okay, so in this example, we're thinking about doing a sliding window approach. So let's this E will represent the end of the window, and then this S will represent the start of the window. And then we also said that we figured out that the product could be held by a integer. So we'll create an integer called product. We're going to have to start that out at 1 because if we start out at 0 and we multiply 0 by some number, it's going to be 0. So we'll start out 1, and when we multiply it by 10, then we'll see that that product is less than our k, and so that would be good. So the scenarios in which it is good is when product is less than k, and then that we would increment the count of our subarrays. Okay, and we also had that. We also knew that if k was 0, we aren't going to be able to find anything. So if k is less than equal to, what if k is 1? So if k is 1, strictly less than 1 would be 0. So that's also 0, right? So if k is either less than or equal to 1, we're just at the beginning of our code, we're just going to return 0. Okay, so we have our subarray count. We have our products like this. Let's see how we can handle this. So when we're here, we would be multiplying. Let me go down here. Say, let's just run through it conceptually real quick. So we have this 10, and that would work, right? So let's mark that real quick. Okay, so that's currently, I'll just go like this. That's currently 1 because the 10 works. Now, if we move this up, then we have 10 times 5, and that works. So so that would be another subarray count. And then when we move up here, this no longer works. This is not strictly less than 100. That's 100 exactly. So we know that we want to get 5. We want to test 5. And then we also want to do 5 and 2. So when we run into a scenario like this, what we could do is we could shrink our window like that. And then maybe we think to ourselves, well, what if we come back here like this and check the subarrays like that, and then we'll go like that, and check those subarrays, and then like that, and then those all worked, and then we come here and bring this back and check those subarrays, and then check those subarrays like that, and then move like that. Okay, that's one thought, but we could do it with better time complexity. Let's analyze these scenarios when we're having these subarrays and how we're going to count them mathematically. So let's look at this. So we got 10, 10, 5, 10, 5, 2. That actually doesn't work. 10, 5, and 10, 5. So that's one group. Let's say 5, 5, 2, 5, 2, 6. Okay, so there's something we have to kind of, maybe this is something that you kind of keep in your back pocket for future problems too. It's something that you figure out on this problem, and then you can remember it for future problems. So when we look at all the subarrays, when we're figuring this one works and we're figuring that one works, we could get all the subarrays. We can figure out that all the subarrays for the count of this is the window size. And I'm going to explain, so bear with me for a second. So we have so we have the subarray count, and then we have plus equals E minus S plus 1. Okay, so let's look at that for a second. Let's see how this is going to work. So if we are here, then this is 1, right? So subarray count plus equals 1, okay? And then we move up to here, and then now we have, this is a distance of 2, so let me write it out like this. It'll be easier for me to teach it. Okay, currently we have 1 plus, and then we're doing 1 minus 0 plus 1. That's this E minus S plus 1 portion. So that ends up being 2, which is 3. Okay, so now we just said 3 here between this. We figured that was an answer, so now we have 3. And then we're gonna, why is that so far? Well, so far, when we're looking at this, watch what this does. There's 3 right here. Let me get rid of this and we'll talk about this one later so we don't waste some time there. So you see there's the 10, we figured that was 1, and then the product of this distance worked 2, so we have 10 and 5. And if we're counting the distances, then that's all combinations. Okay, something that we just learned is that if we find that a window works, then all combinations of that window is just the size of that window. Okay, and this is something that, it's like a big revelation, and to gain confidence of this, we're going to do a couple more. So let's do a couple more. So now we have 3. We figured out these 3. We're going to go here. That doesn't work, right? So because that doesn't work, we need to move this window. So when we move that out, we're going to divide the 10 out of our current product. So our current product is 100. We're going to divide it by 10. Okay, and that brings us down to 10, which is what we have in our window, 5 times 2. Okay, and so this is 3 then plus window size 2, which equals 5. Okay, why is that? Well, now what we have here is we have 5 and 2, and we have 2. That's those two other ones, 5 and 2 and 2. So, and you sum these up, that's 5. So then we go this next one, and that's going to be 10 times 6 is 60, so that works. That's less than 100. The distance of that, so we had 5 right here, right? So 5 plus our distance, which is, or our size, which is 3, because we said 3 minus 1. I'll just do it in there like that, plus 1. So there's 3, which is 8. Okay, why is that? Well, if we look at this, we have 6. We have, what else? 2 and 6. And we have 5, 2, 6. This is something really helpful for us to keep in our back pocket for future problems, that window, everything in that window, all the combinations of what is in this window, the count of all that is just the size of the window. This is really helpful for us to mark down on like a piece of paper so that in the future problems we can utilize that. Okay, so now that is good, and notice this. We don't have to worry about, like, E's already at the end here. We don't have to worry about moving this up because we already figured out, we got the count of all those combinations. And then now the problem's over when we move it up like that. So, so let's see. So in our current problem, we have just had to subtract by 1, but let's see what happens if we have like a bigger problem where we have to move this up multiple times. So picture that. So when we're here, and that was 100, and we had to move up here. What if this window was too large as well? It's not, but what if it was? Then we know that when you solve these other sliding window problems in the playlist, so go to my sliding window playlist and you'll solve those other problems. You'll see that when the window, what was in the window was still too big, like if you move up one, if we're trying to get the whatever is in the window, if the whatever it is in, sorry, whatever is in the window, if it's too big, then we'd move it up, right? And if it's still too big, we would move it up, right? So that's super familiar. Like we just need to have a while loop that's going to keep on shrinking this window until what is in the window is less than k. So let's go code that up. So we'll start with Java, and then after Java, we'll do Python. Okay, so our first thing we said was that we have to check the k to see if it's less than or equal to 1, because then it's just going to be 0 if that's the case. And then next, we wanted our subarray count starting at 0, and then we knew that the product had to be 1, because if it was 0 and we multiplied 0 by anything, it's going to be 0. So it has to be 1. And then now we're going to do our window, our sliding window loop. And then we're going to have our product times equals the nums of the window end. Because here we're going to start right over here and we're going to multiply this and say, okay, that's 10. So that's, now we want to make sure that this window is going to work. We need to make sure that the product of whatever is in this window is less than or equal to k. So that's where we'll do our loop. So let me set this situation up. Remember when we were at this situation and we realized it was too big? Then we knew we had to shrink our window, and we have to continue to shrink our window until whatever is in our window is less than or equal to k. So we'll write that. So we'll say while the product is, if it's greater than or equal to k, then we need to shrink our window. So the product like that. And then we don't have to worry about like this overrunning the bounds, because remember our k is going to be some number. It's going to be at least 2 or greater, right? And we're dividing. So if we end up, if this window start is right on top of the window end and we divide that, that's going to be 1, which is going to stop this loop because 1 can't be greater than 2. So we're good. We don't have to check to see if our window start goes past nums.length as a result of that. Okay, so then now we have that special thing we learned that we're going to keep in our back pocket for future problems, is that all the subarrays, all combinations, we can get the count of all combinations by just getting the window size. So everything that's in that window size is all the different combinations. So remember that is, let's look at this window right here. So all the combinations of what's in this window is just the length of that window, which is 3. 6, 2, 6, 5, 2, 6. And that's for this problem. I mean, there's also 5 and right, but we had already taken that into account by getting that earlier when we did the window size here and we did the length. We had 2 earlier, which was these two, 10 and 5 and 2. And then when we got to here, and that was another one, right? And then another one. So I should really say all new combinations, right? So like here, all new combinations that we haven't already accounted for are the size of the window. So here's all new combinations, which is just 1, and then all new combinations, which is 2. And then that doesn't work, so we'll shrink all new combinations, which is 2 more, and then all new combinations, which is 3 more. Okay, so we handle that with this, and then that's it. Then we can just return the subarray count. So let's run that. And then we'll submit it. Okay, and then now I'm going to move on to the Python. Okay, so here what we're going to do is, remember we had said that if so k can be 0, k can be 1. So if k is 0, then anything strictly less than k, we're not going to have it, anything that's going to satisfy that. We're not going to find any product less than 0, so that doesn't make sense. So we have to check to see if k is 0. If it's 0, then the answer is 0. If k is 1, then the answer is 0 again, because we're not going to have any product that's going to be less than 1, which is 0. So we go do our special check where we check to see if k is less than or equal to 1. We know that's a scenario where there's not going to be any subarrays because we're just not going to have a product. A product is 0, basically. So we're not going to have a product is 0. So we return 0, and then we have to keep track of our count, like the count of the subarrays. So we say subarray count equals 0. And then I'm going to do this camel case, even though I like underscores because the existing code base chose camel case. So, all right. And then next, what we need to do is the product. So we decided that the product, this variable that we're going to use to keep track of the current product, it's going to start out at 1 because if we did 0, anything times 0 is 0. So we start with 1 and we say 1 times 10. And we see that's 1, so we increase our subarray count. And then we, now 5 enters the window, so we multiply the product, which is currently 10. We multiply that by 5, so that becomes 50. And then we add to our subarray count the distance here. So the good thing about this problem is it teaches us something, some trick I would call it, that would be useful for future problems, which is the all combinations is the count of the window size. So when we're here, we have, and I should say all new combinations. So all new combinations, so we don't have any combinations currently. So all new combinations in our window is 1. So let me do this. All new combinations, which is just the 1 is 10, right? We have the value 10. That's one of our combinations. So all new combinations, there's just 1, and then now all new combinations of this, well, that's the window size, right? We always add on the window size. All new combinations is just the window size. So now we have 3. Why is that? Well, all new combinations, here's the new combinations, 10 and 5 and 5. Okay, and then we go here and we see that doesn't work. So we're going to shrink the S as long as the window, whatever's in the window, does not work. So we continue to shrink the S as long as whatever's in the window does not work. So what's in the window now does work. So all new combinations is the window size. So we add on all new combinations. So we have currently we have 3, and then now we add the window size, which is 2, so 5. And why is that? Because here's all new combinations, 5, 2, and 2, which is the window size. And then we increase this, and all new combinations we add on, which is the window size. So 5 plus 3, which is 8. And why is that? Well, here's all new combinations, which we'll see is the window size. It's 5, 2, 6, 2, 6, and 6. So that's a new trick for us, is that all new combinations is just the window size, and we can make use of that in future problems to write some really elegant code. So let's do that. So we're going to have our sliding window. So we'll say window end in range length of the nums, and then our product is multiplied by the window end. And then we decided that we need to continue to shrink the window as long as whatever is in the window does not work. So as long as whatever this product is, if that's greater than or equal to k, we need to continue to shrink the window until that's no longer the case. So we'll make a while loop that says that as long as the product is greater than or equal to k, then we need to shrink. And the way we shrink is we're going to divide from our current product whatever the window start was pointing to. So window start plus 1. So let's look at this. So here's this window that does not work. So we need to, and it's currently 100, which is what it is in here. So we need to divide out that 10, which now, when we divide 100 by 10, the result is 10, which is what is in our window now. So that's why we are going to divide out what points to the window start. Okay, and then that subarray count, we're making use of the fact that all new combinations is just the window size. So window size is calculated by window end minus window start plus 1. And then we just return that subarray count, and that's the result. Window start reference, I must have misspelled it. Oh, I never declared it. So window start equals 0, go. Okay, and then we'll submit it. All right, and it's accepted. So if you like this video, if you enjoy it, please motivate me to make more of them by subscribing to the channel, and then also like the video because it will help YouTube decide to show it to more people so more people can subscribe, which gives me more motivation to make these videos. All right, thank you. And if you want to see more of these types of videos, look in the video description. There's a playlist to the sliding window problems I made, and then there's a playlist to two-ported problems that I made too. All right, thank you. Bye.